Good morning, everyone, and welcome back to Machining Harmony, the Tools and Softwares in Concert series, co-powered by Domopromet and Mastercam India. We are here in session 4 of Precision and Productivity in Die and Mold Machining. This series is focused on one critical truth in modern manufacturing. A great machining happens when tools and softwares move as one. So, in die mold machining, there is no room for compromise. Precision must be exact, productivity must be consistent, and performance must be repeatable. So, let that's the focus of today's session. So, we are very excited to see what lies ahead. Before we begin, a few important reminders. Please follow the local safety procedures wherever you are joining us from. From cybersecurity point of view, this session is fully secure. Any links shared in this session are verified and safe. And most importantly, this is a psychologically safe environment. We encourage open questions, shared experiences, and respectful discussion. A few housekeeping rules to note to keep this session seamless. All participants will remain muted for audio clarity. Please use Q&A panel to submit your questions at any time during the session. We'll take up as many as questions possible in the Q&A segment at the end. This session is recorded and the recording along with the presentation materials will be shared to you post this event. If you face any technical challenges, try logging out and then logging in. This resolves the issues. And now moving ahead for agendas and speakers. Would have welcome remarks, opening speeches, and then technical presentations, and then we'll be moving ahead to Q&A. So we have opening remarks by Vineet Seth, Managing Director, Mastercam India, and Amit Rana, Vice President, India Sales Dom Pramet. Over to you, Amit and Vineet.
Good morning, Priyanka. Do I begin or does Amit begin?
No, Vineet, you can begin, please.
All right. Thanks,
Good morning.
Amit.
Yes, good morning.
Good morning. Good morning to everyone and welcome to the session. Thanks for taking the time. Die mold, I believe, is the backbone of the manufacturing industry worldwide, not just in India. And India has taken leaps and bounds, taken it forward to being a secure and a modern provider of very high quality toolings from both the die and mold and the press tools fraternity segments. I'm going to break my narrative into five separate segments, touching briefly on each one of them. Let's look at why die and mold matters and matters more today. It has always been the foundation of manufacturing, and therefore quality, cost, and delivery are very important here. The demand, despite all the doomsayers that said the EV segment will bring about lesser die and mold requirements, has been proven to be otherwise so far, and the demand has been rising across both automotive and electronics and medical and packaging industries. We are seeing more and more investments being made into producing better quality and higher throughput of die and mold. And therefore, the existing tool rooms and the upcoming ones are under tremendous pressure to deliver faster and to deliver more consistently and to deliver higher quality. Um, Secondly, let us look at where India stands in the ecosystem of die and mold. Um, and without naming anyone, we are a plus one opportunity. We have been one for a while, and we are seeming to be getting more entrenched into the plus one narrative for every manufacturing activity, but more so in die and mold. Um, the OEMs are actively qualifying Indian companies for tooling and production. And therefore, the focus shifts tremendously on reliability, consistency, and scalability of deliveries. Um, it's not just about cost alone, it's about cost plus quality plus delivery times. And therefore, we move from just capacity to capability. Um, Machines are no longer a constraint in India. We are able to manufacture domestically. We are able to import machines without any major hassles. But therefore, what differentiator comes up is the process maturity. It's important to get the machining or the output right the first time rather than through an iterative process. And there are certain hidden costs which need to be tamed or brought under control, which is like rework or polishing or things like that, which are a hidden cost of sorts. And therefore, the innovation in die and mold manufacturing is not just about new machines, tools, or software. Innovation today comes from the harmony, which is the topic of our discussions as well, between how tooling, CAM, and the machines work together to produce the best results. No single or singular utility will work out beneficially for everyone or anyone for that matter. And therefore, collaboration becomes the enabler for growth across the entire ecosystem of die and mold manufacturing, which is the topic of our discussion today. When our customers need or want to become globally competitive, they need to be backed by strong technology partnerships that the kind of which you see from Dormer Pramet and Mastercam in the current instance. And therefore, the software and tooling needs to work in harmony, and knowledge sharing is increasingly and very important as an investment. With that, I hand over to Amit and to the rest of our presenters today to take you through what Dormer Pramet and Mastercam have to offer. Thank you very much, and over to you, Amit.
Thank you. Thank you, Vineet. Thank you for your deep insights in die and mold industry. Again, good morning to everybody and welcome to this Machining Harmony series. First of all, I would like to thank all the viewers here for their continuous support in 2025, and that has helped us to maybe bring this series again back in 26. Starting with die and mold, like I think Vineet has already shared a lot of insights. I will only add that die and mold is an industry segment which not only impacts one but impacts many things, and because die and mold is in essence related with many things which are directly manufactured or even like pharmaceuticals, everything is related with die and mold, and it impacts everybody. And the peculiarity of this industry has been that it started with a very niche where being a tool and dial maker was always a niche, and with today with technology, specifically with the CAM and CAD and all those things, I think it has become more general, but at the same time, it requires a lot of competence, because we know die and mold is a normal segment where you can go from 2D to 5D, and you need to have all the experience and technical experience, not only from a cutting tool point, but also from programming. This is a true, you can say, segment where the software, the machine, and the tool have to really work in harmony to give the best results, whether it is in time of quality, delivery, lead time, and also from an Indian context, like what Vineet said, maybe India is the +1 opportunity, and I think so die and mold is key to it, because maybe in past also and maybe till now also we have been importing a lot of dyes, and as we go ahead with the made in India and being more Atmanirbhar, it will be really meaning that more die and mold, you can say, opportunity will come in India, and I think so I'm looking forward to that. And again, this Harmony series is a step in that direction. How do we share knowledge? How do we see that global competencies are brought to India, and how we collaborate with Mastercam, who's you can say a top runner in die and mold. If you talk about the whole die and mold market, I think Mastercam has the biggest presence here, and it is most easiest to use. And along with Dormer Pramet tool, I think it's a very win-win situation. So again, once again, thank you all for your presence today, and over to you, Sandeep. Thank you.
Thank you for those insights. They have perfectly underlined the importance of collaboration in achieving machining excellence. Now, now it's time to move to heart of today's session, that is technical presentations. So please join me in welcoming our technical specialists, Sandeep Pandey, Product and Application Manager, Dormer Pramet, Sutanshu Mohanty, Technical Director, Mastercam India. Over to you, Sandeep and Sutanshu.
Yes, good morning and welcome you all for another session of Machining Harmony series, the tool and software in concert series. The topic for today is precision and productivity in die and mold. So I'm Sandeep, a product and application manager in India. I comes with a 17 year of work experience in machine tool and cutting tool industry. So this is a brief intro about me. Over to you, Sitansu. Sitansu, I think you are on mute.
Sorry. Thank you, Sandeep. Good morning, everyone. I hope definitely this seminar will provide you valuable insight into the die mold machinings. My name is Sitansu Mohanty. I'm the Technical Director of Mastercam India. I support customer across India, Middle East, and Southeast Asia. I have over 25-year experience in CAD/CAM industry. In my early part of career, I working in a tool room environment and gained hands-on experience with the multiple machines and the CAD/CAM software. Let's go to the today's session, which we are going to discuss. Next slides, please. Precision, productivity, and die mold machining. Everyone knows that die mold machining represent one of the most demanding application in manufacturing, and complex geometry, hardened material, which is to increase the life cycle of the part, deep cavities, die mold, you cannot decide it's a small height or deep cavity. Always you will find there is a larger depth and cavities you will find in the market, and extremely tight expectation on the surface finish as it's a aesthetical look. Most of the part you can see in the outside, so it's very demanding. It should be a surface finish is the most important part. Today's session about how software and tool must work harmony to deliver the result expected by the market, expected by the owners, vendor, and everyone. That we are going to discuss in the further slides. Next slides, please. So what is harmony? Harmony means it's aligning between the digital strategy with a physical cutting behavior. Like geometry is a CAD model, tool path, tool, cutting conditions, all together into a one system to uh, give you a output. Only a cam system, everyone has already mentioned, that only a single cam system is not enough. Single cutting tool is not enough. So it has to be work together to achieve the saving, achieve the output which is required. If you show this particular image, we can by working together, machines, tool path, cutting parameter, everything working together, we can able to save more percentage. Like I have mentioned here is the very minimum of 15%, but you can achieve 40 or 50% time of saving that Sandeep can explain in the next slides. So how major cost can be saved by working together, and we'll discuss further slides. Next slides, please. Sandeep, can you just give a brief what factor we should consider to
Yes.
reduce the cost?
Like we discussed that maybe not maybe only the software or only the tool or only the machine is not going to help. So it is the harmony of everything where we should work together and we should get then only we can get the best output. So let's understand when we talk about the best output, maybe how we are going to get this maximum benefit. And before to understand this, let's understand the cost structure of a die, or maybe for any manufacturing or maybe any component. So when we will see this, so we will find that maybe the 75% cost is fixed and only 25% cost is variable. Where you will see means like the material cost is around 22% and just tooling cost is just 3%. So it means like maybe if you will just focus only on reducing the cost of the tool, you will not be able to get the best of it. So what you need to focus? You need to focus on the rest 75%. And how will you get that? Just by improving your productivity or reducing your the cycle time. So if you reduce your cycle time, if you'll improve your productivity, you will directly impact the 75% of the cost of your die. So and that's what we are here. That's why we are here. We in collaboration with Mastercam, Develop Pramit is able to provide you that kind of productivity benefit and the cycle time reduction. What's your input on
Absolutely.
this, Siddhansu?
Absolutely, absolutely. If you Sandeep, most you have mentioned that 75%, which is a large portion of any part or any productions, is a labor cost
Yes.
and the machining cost. These two things we can control. Labor cost, like today's world, the machines and the tool has been come to that level, and the software come to that level that we can get a mirror finishing without polishing, where you can reduce the labor cost. I'm just giving example of one topic. And then the machining cost, because of correct selection of strategy, correct selection of tools, we can able to reduce the cycle time drastically. As I mentioned, 15%, not 15, 40% or 50%. That is the major cost we can. People has to think, the vendor, the customers, the programmer has to think, only focusing on the tool or software reductions. If you focus on the correct tool, correct software, correct machines, then you can able to achieve many things. Let's go to the next slides. Let's understand what is the hard reality of die mold machining. Die mold machining, as I told you initially, complex profile, deep cavities, hardened steel, and tight tolerance. These are the major factor which is going to affect on your die machining. But the we should understand, to overcome these cases, what are the losses. First, we have to understand what are the losses, then how to overcome. Go to the next slides, please. If you go through this particular image, you can able to see there is a major losses. We may not be, as a programmer, as a owner of a company, we may not be focusing on those losses. Let's understand how to reduce those losses. If you are using most first point, I'll take it into the picture, that air cutting. When you are discussing this, air cutting is a major losses because it's a non-cutting movement. But by using the correct software, you can able to overcome this problem. You have to do a correct rest roughing operations. You have to do a perfect roughing operation, rest roughing operation, where it always engage, tool will always engage with the material. There come you are able to reduce the overcome, because the air time is more, then your cycle time automatically increase. Non-cutting, but your machine is running, your spindle is running, oil is running, everything, machinery is running, but you are not cutting any material. So correct use of software will definitely help you to reduce the air cutting. Second option will be the second losses will be the spike, engagement of spike. When you go for a traditional strategies, traditional old strategy long back, where you are going with a small feed, small parameter, then that time it was okay. But today's world, if you go with a higher parameter with a sudden spike in the tool paths, it will break the tool. It may load on the tool. It may increase load on the spindle. So many issues will come across. So use a correct strategy which can help you to remove the spike movements, remove the uniform contact angle into the material, and it will try to remove maximum material removal. So those are the options. Those are the losses we have to focus. How will focus with the help of software, help of the tool, like in the deep cavity vibrations. Vibration is definitely you'll find it. Sandeep, can you suggest how we'll reduce those
Yeah.
vibrations by using a proper tool with a software?
Yeah. So maybe like you said, and like we talked about the die mold and the productivity part. When we talk about productivity, so you can directly correlate with the machine hour rate, and maybe what we are talking about, the 75%, the fixed cost, it is nothing but the machine hour rate. And you know that in these situations, the machine hour rate is so high for the new machines, and by improving the productivity, we can achieve that. And these are the losses which these are, maybe you can say, these are the hurdles which maybe which gives us means which stops us in achieving the best productivity. And out of which is, again, one is the deep cavity vibrations. So deep cavity vibration is a very common, means I would say, if it's a die, so you will most of the cases you will see such kind of operations where you need to go in a deep cavity, and because of long overhang of the tool, or maybe the long setups, you can face these kind of issue. And to overcome these, maybe you could have you can have the both of them, like maybe when we talk about the dynamic milling strategy from the software point of view, you can go with the dynamic milling strategy where you go for a higher depth of cut and the lower AE, which can again reduce the vibration, instead of maybe using a simple solid carbide end mill. You can go for a barrel cutter, which can give the strength of the tool, and also it can improve the productivity. As well as maybe sometimes we miss the tooling system part, maybe the holding system. You can, rather than using for a simple well down check, you can go for a power check, which can again reduce the radial forces. So all these things can combine, means like you can overcome the issues of vibrations in deep cavities. And talking about the heat in hardened steel, so again, it is a very, again, it's a common phenomena. And maybe by using a right tool, and maybe so again, talking about the strategy part, so you should be using the right tool path, so that your tool doesn't come to the job and it should go away from the job. It should not come to the job or maybe to your tool. So to avoid the heat directly coming on your tool or coming on your job. At the same time, your tool should have the good geometry to handle these kind of materials. You should have the negative rake angles, so that you can your edge have the more strength to support this kind of workpiece material. And as well as maybe you should using good coating technology, so that your tool can run
Absolutely, absolutely.
longer tool
Because
line. Yes.
yeah, absolutely. Because of
Right, right,
the
sir. Yes,
tool
please.
design in such a way, it will transfer the heat from the tools to the chips. That is the important
Right.
point over here. And also dip cavity. When you're machining a dip cavity, you should go for a shrink fit kind of a thing. So here you can give the more
Right.
rigidity other than conventional method of holding the job. And most we should understand, most inefficiently do not come from a big mistake. They come from a small mismatches between the tool path and tooling, and that compound across the process. So that we need to understand in detail. Go to the next slides, please. So in this case also there is we have already discussed the number of losses. Again, we are discussing losses regarding the semi finishing. So you know that people think, if mostly the programmer, because they are always under a pressure to minimize the cycle time, but that does not mean that you should remove some process or steps. But because of that, people, what they do, they create a roughing strategies, then directly go to the finishing strategy. As you know, die mold industry has a complex profile, complex area. Some of the area may not be reachable by the larger tool. So there is a, if you go for a roughing without doing a semi finishing operations, when you go for a finishing operation, you will find there is a variations in the material. Some area it may be keeping a standard whatever the material left out is 0.2 or 0.1, other location 0.5, 1 mm, because you have not done the semi finishing process correctly. You have not done the semi finishing operations. So because of
I
that,
would
in
like to add here,
finishing,
Sitanshu, one thing. Many of the times, maybe why this is important, the semi finishing is important, and many of the time, what people does a mistake. They try to, most of the time we do roughing with the high feed cutters, and you remember you know that in high feed cutters, the programmable corner radius, that's what we put in programs. So most of the time I have seen that even the people doesn't put the right programmable corner radius into the program. And also it is a theoretical corner radius. So if you will put this corner radius into the program, so it will leave uneven stocks sometimes. So that's why in finishing, in semi finishing strategy, we go for a round kind of inserts, where so that the stocks can be even. And for your finishing tool, it gives a even stock, and you get a better surface finish and better profile structure.
yes, yes. So my request, people should understand that. Also regarding this manual polishing, nowadays machine has been, machine tool software is much more capable, that we should use the correct strategy, correct tool and correct parameter to get a mirror finishing. People think that we will just machine or surface finish manually, we will polish it. That manual work take more than the time we have already consumed on the machines. So that's also we have to understand. If you have a correct tools are available today's world, tools, software, passes, movements, machines parameter is high RPM and high feed, you can able to use it. So correct tool selection is a most important part. If Sandeep can explain you more how we can select the correct tool that will give a strategy wise, it is available in the software set, but tool wise, you can able to explain it. What are the major discussions we should do before going any kind of a finishing strategy?
Yes, so maybe like we already said, we should be knowing all these parameters what we should use in the programs. I have seen this the third loss what we can see on the screen, that the tooling discussion in isolation. So this is one of the biggest mistake generally what we see in our industry. So generally what happens many of the time we observe that maybe the programming team is different, the tooling selection guys are different, and
Absolutely.
they do the selections all means all different in all different way. The tooling guy doesn't see the program and the programming guy doesn't see the tool. So what happens, like maybe for example, I give you one example. Maybe my cutter can take a ramping angle of 8 degree, but you have put a ramping angle of 4 degree in program. So what's the point? Maybe by putting 8 degree, you can get a more MRR. In the similar way, if you are putting a wrong programmable corner radius, you can maybe end up rejecting your die. Maybe if you are putting a lesser programmable radius, it can cut a more material, and your die can get rejected.
Absolutely.
So you should be putting the right in to the program. You should be giving the right strategies by seeing the tool. If you are doing it completely in isolation way, then it can again lead to a bad out for your component or for your die.
Right. And regarding this
Yes.
visibility, like the all
Yeah.
software has a options to visualize the simulation completely and understand how whether it is tool holdout is most important part. We do see the collisions on the things. So everything you can visualize, run, see the things, then you process into the G codes and M codes. That is a tool deflection is a major issues, Sandeep, nowadays. Can you just give a brief information about the tool
Yes, yes,
deflection
yes.
as well?
So
So that helps the
exactly.
programmer
So
to understand.
yes. So can we go to the next slide, please? Yeah, so it's really an important topic. We are talking about the strategies. We are talking about maybe the tools. So now let's understand how a strategy can, or maybe how a tool path can make a difference. So on my screen you can see there's a conventional milling which generally we call up milling, and the climb milling generally the term is down milling. In another terms you can say it down milling. So it is a myth that maybe every time when we talk about, so if you ask people in generally, so they will say the best programming strategy or the best tool path is a down milling. But let's understand what is happening here. So on my screen you can see the on your screen you can see that on the left hand side and the bottom end you can see what is happening here when we are going with a conventional milling method, and we have kept A just 0.25. So what is happening here? You can see the red arrow. Your tool direction is going, your tool is pushing away from the material. So what it means, it will automatically, there will be no vibration mark, there will be no chatter mark or the rubbing mark on your component surface. Okay. Whereas if you see, let's go in the climb milling operation. In climb milling, on the right hand side on the upper picture, you will see where we are going AE 0.75. So again, what is happening? Your tool is pushing to the away from the material. But if you keep a lesser maybe the lesser AE, then in that case again the tool is getting into the material in climb milling. So it will rub the material, it will rub the tool. All these things can happen. So in short, you can see if you want to go for a heavy MRR, so you should be going for a climb milling setup, climb milling tool path process, or maybe if you want really good surface finish or good machining, then you should have opt for this conventional milling
Absolutely.
method.
I follow a simple rule to remember.
Yes.
Climb milling is cut faster, conventional milling is safer. So rough
Yes.
always
Great. Great.
climb, finish with the conventional. That's the funda we have to use while doing the programming
Perfect.
part.
Right. So can we move to the next slide? Yeah. So we talked about like how a tool path or how a strategy can make a difference. Now let's understand how a tool can make a difference. We are talking a tool, it's a harmony of tool and software. So we talked about the tool path, and now let's understand the cutting geometry or maybe cutter design can make a difference. So you can see on my screen, there's maybe you can see a mass hanging over to a spring. So what happens because of the mass? There is an energy. It comes and it pulls the spring back. But when the spring goes down, the back there's the energy gets stored into the spring, and it pulls again back the mass in the opposite direction. The similar phenomena happens with your tool also. When your cutting edge gets engaged with material and when it leaves the material, so there's a lot of energy is getting stored in your tool, and which result in the part of in the terms of deflection. And if you are not using the right geometry, for example, in my screen, you can see 1, 2, 3, 4, 3, or maybe four type of tools is there. Whereas you can see in one, there's a very high relief angle has been given. In second case, there is a margin, and then there's a relief angle has been given. And in third and fourth, also there's a smaller margin and a smaller relief angle has been given. So what is happening here? So if we will give maybe a overall relief angle, maybe it can work better in aluminium, but it will not work very good in steel and other materials or super alloys. So for example, here we have given two pictures in steel machining. In the first picture, you can see a very wavy surface finish, but we have given a very high clearance angle. In the second case, we have given a little bit margin, and then we have given a clearance angle where we can see a very good surface finish. So in the second case, what is happening? So we, because of the margin, the cutting has got the strength, and it has given the dampening effect to the tool, so that our tool is not moving and it is giving a clear, a very good surface finish. Depending on material, depending on the strategy, maybe your tool should be designed, and that's what we Dormo Parameter do. We have a different kind of geometries, we have a different kind of maybe the what we say, different kind of helix angles, different kind of rake angles with the end mills, which can help in achieving your targets.
Absolutely. Depending the combination of the relief angle and the margin, when it combines, it gives a
Yes.
proper finish, proper kind of a chip removal. Everything will come into the pictures. That definitely
Right.
helps the programmer to work perfectly.
Yeah. So can we go to the next slide? Yeah. So now we talked about maybe the strategy, we talked about tool path strategy, we talked about the cutting tool. Now, what is our approach in Dormo Pyramid? What is our approach for customers? So we don't just give the solution, we give the application based solutions. So depending on your need of application, we suggest you the solution. We gives you we have the complete covering range from roughing to finishing, like we talked about what tools the different tool is needed for roughing, and surely a different tool is needed for semi finishing and finishing. We have optimized geometry, what we saw in the previous slide, for different kind of workpiece material. We focus on process reliability and productivity, and obviously this one important aspect that we have a strong application support in all across India, where wherever you feel that you need any kind of application support in terms of improving your productivity or reducing the cycle time, please reach out to us.
Yeah,
Can we move to the
definitely.
next
This
slide?
kind of a engineering support definitely help
Yes.
them. Like as a programmer, they sometime I have seen some of the industry, not everybody. I'm not standardizing a statement. Some of the engineer they thought a particular tool can be used for the aerospace, medical, die mold, everything. The Dormer Pyramid has a multiple set of multiple tools are available, which can be used for the different application. We should discuss and understand the things. Then that will help to increase our productivity along with the software strategies.
Right. Right. So yeah, next slide, please. Yeah. So when we talk about die mold, so in die mold, I think most of the things is done by milling. So that's why I have given this topic, the milling, the heart of die and mold machining. And we at Dauber Pyramid, we have the entire range to cover your milling needs. So whether it is roughing, semi-finishing, or maybe it is needed for hard milling, hard metal machining. We talked about tool stability, or we talk about the right tools which gives your which can improve your maybe the confidence in machining and productivity. So talking about high feed milling, so we have the two cutting edge high feed solutions to 8 cutting edge high feed solutions, which can improve your talk about the like which can again at the same time you can improve your productivity improvement, and you can with the 8 cutting edge insert the SNGX, you can get the benefit of cost reduction. The face milling solutions, the ONMX 16 coming with 16 cutting edge to a PNMU 13, which can take a depth of cut up to 10 mm. Then we have the entire range for the copy milling, ball nose insert, the modular balls, the indexable balls. So the complete solutions is there, and the most important, we have the specific end mill series for the dynamic end mills. I remember our first session on dynamic milling, where we talked too much about on dynamic milling and the barrel shaped cutter. So we have the entire series for the dynamic milling, which is coming, which is a new trend in manufacturing industry, and people are now moving from conventional milling strategies to the dynamic milling strategies. So we have a dedicated series for that, which can help you in achieving your productivity improvement targets.
Yes, yes. Dynamic
So
milling will help definitely to reduce the cycle time drastically because it's a
yes,
roughing operations, and it can be by use of this particular tool, carbide tool, and the strategy, drastically it will reduce the cycle time for this dynamic machines.
right. Next slide, please. So yeah, so I talked about milling, but it doesn't mean that Dollar Promet doesn't have the other solutions. So we have the entire solutions which can cover your machining need for the die and mold. So we have the hook making solutions, 4-6 generation tool drills, which comes with a continuous thin web design, and the S-shaped chisel, which can improve, which can enables the higher cutting feed rates. The forced deep hole drills starting from diameter 3 to dia 20 up to LYD 20. Then we have the forced micro drill from 0.75 to 2.95. Then if you have the breakage issue in solid carbide drill, then we have the parabolic flute, the PFX series, HSS E drills, which can improve, which can be a better option compared to HSS, where you can go get a more parameter and the more tool life. And then the modular drills coming up with the solid carbide head and the steel body. And then we obviously the indexable drills. Talking about threading, so we have material specific shark taps. We have the dedicated black shark tap for the hard materials, which is a challenge for the industry, which generally many of the people are not able to do tapping in a material having HRC of like 55 or 60. So we have a dedicated shark series taps, which can help you in doing tapping in such kind of workpiece material. When the universal taps, general purpose taps, roll taps, hand taps, as well as the solid carbide thread mills. Talking about hole finishing, so we have a boring range from diameter 8 to 500 mm for roughing and with the semi finishing. We have the fractional sizes reamer in standard. So for example, in fractional size of 0.01. So let's say, for example, if you need a 7.05 reamer, so it could be an option that where you can get a standard reamer with Dorma Promet with B481 series. Then we have the carbide taper shank reamer, pin reamers, and obviously, and for general machining, we have a general purpose solid carbide end mill from S9 series, the chamfering cutters, profile cutters, T-slot cutter, and side and face mills. So next slide. In one shot, I can say Dorma Pyramid can be your one-stop solution for die and mold machining. So our assortments setting the highest standard, including process security for die and mold markets. With our portfolio, you can get the solutions for all kind of operation, for all kind of workpiece material. And one more important point, I would like to emphasize here. So we offer technical advice. And thanks to Mastercam for collaborating with us, where we can support you with the CAD cam as well. And we can deliver you the complete customer service.
Yeah, absolutely.
Start to what's your view on
Yeah,
this?
by adding this technical advice and everything, I'll add on the more points how together, because as a single entity or single point you cannot success in your life. So it's such a combinations. It's a combinations or partnership is very important in this. Let's go to the next slides. I'll explain you. It's
Yes.
from CAD to chips. From whatever the CAD model you have got it from the customer or vendor or from your design department, that has to finally ended with the chips by removal of chips and getting a final output. But geometry alone does not define the machining success, because CAD is good. That does not mean that my final product will be good. So many things are involved. A CAD model only defines the shape. It does not define the process. It does not define how my tool is going to enter into the material, how the heat is going to manage during machining, how the vibration is managed during machining, how the surface finish will be generated, how the surface finish will get a better achievement. This behavior is defined by the CAM strategy. CAM strategy will help you tool engagement, heat along with the tools, and the vibration along with the tools. So every time it's a combination of tool, machine, and software will give a complete package, complete information to control. That's why we call it as harmony. It's a combination of tool, software, and machines. This chain of everything is give a final output. If one of the chain is not proper working, so you will not get the final output. So we try to convert geometry to the toolpaths. Toolpath create the cutting conditions with the dependency of tool. Cutting condition interact with the tool geometry, transferring the heat. The passes should be created like that. It should load on the tool and load. Tool will transfer the heat to the chips, not to the tool or the material. So all those interactions, everything, it increase the tool life. It increase the surface quality and productivity. These are the things which to combine to give a final result. So we have to always think about the harmony. We have to always discuss with the tool manufacturer, always discuss with the machine manufacturer, always discuss with the software people like us. So everything you have to programmer has to very open mind. He has to discuss and he has to make a program. Then only he can able to get a better result. Next slides, please. Yeah, controlling engagement. Say when you go for a traditional process, traditional offset toolpath like we do in the roughing strategy, most of the time we can get it the sudden engagement of spike. I was explaining in the traditional method, you'll definitely get a sharp corner and step down, many vibration, many damage into the tool, damage into the machines, damage into the part, everything can be happen. To avoid such conditions, as we are discussed with the dynamic machining. Please go to the next slides, please. So dynamic machine will help you to reduce the cycle time of those operations and those overcomes to overcome all those issues we are facing with the normal methods. But in today's industries, we need faster, we need good final output. So tool has been designed to support this kind of a operation, dynamic operation. Strategy has been designed. So all the time tool will engage with the material with a specific degree. That is we call as control engagement angle. There is no air movement to maintain the cycle time and smooth entry and exit. That will help us. So when you are met, and as I told you in the initial, die has a combination of core and cavity. The software has to decide where to entry and how to exit and how I am going to approach to the material. That is also make a bigger, because in dynamic machining we are going a depth of cut twice or thrice of the tool diameter. 10 tool, we may go 20 to 30 depth of cut. So if I suddenly go inside the material, it will break. So that is entry exiters play important role over here. So by this dynamic method, we can able to reduce our cycle time drastically. Okay. Next slides, please. Also, we discuss about the rest machining or rest semi-finishing operations. It's a request to all programmer, all viewer. We should not use roughing and the finishing directly. We in the die mold industry, especially die mold industry, other industry we can use it, because aerospace we can use the roughing and directly we can go for a finishing because there is a kind of a pocket machining. But in die mold industry, complex profile, complex shapes, to so we should use the rest roughing operations. That software has capable to reduce the air cutting, unnecessary passes, missed out material, because due to stock model calculation, software has options to identify where the material left out, and it will only approach into the those areas, and it will try to finish as much as material finished by that particular tool. So we should not always sorry, we should not always think that go for a roughing and the finishing. We should always think about roughing, semi-finishing, rest roughing, semi-finishing, and the finishing. This is the flow we have to always. It's a request to everyone should follow this process in the die mold industries. Next slides, please. If you go to the screen, you can see there is a red mark on some of the strategies, not all the strategies. These are the dynamic motions. Dynamic strategy we support in the 2D as well as the 3D. There is a different dynamic requirement as per your requirement, which strategy to apply, which locations, which tool has to use. Again and again, I'm emphasizing the point of discuss. If programmer discuss with the tool manufacturer, discuss with the software vendors like us, so we can able to suggest which strategy should be used for this particular job. Each job has a challenge. I cannot say I am using a XYZ step that same has to follow for the everything. It's not like that. That's the losses we are doing. If we are continuing with the existing process, we are doing the losses as I explained in the initial stage. So we are doing more losses. Instead of that, connect with us, understand the part, understand the process. We'll definitely, our team will help you. Then you'll go for the reduction of time and the good finish. Next slide, please.
So I would like to add Siddharth here. So like we are discussing here about this the synergy about tool and the software.
Right.
So like you discussed about the maybe all tools cannot work for the 3D milling, or maybe all tools cannot work for maybe the different kind of operation. Maybe some tools will be having the lower capabilities of like maybe they cannot maybe plunge, or maybe they cannot having the high ramping angles, or maybe they will not be having even the ramping. Such time maybe time we should understand all those strategies, and we should be discussing like the tool selection should not be in isolation. It should be parallelly with the
Ab-
software guy or maybe the programmer guy, and then only we can get best output.
Absolutely,
So this is
absolutely.
it. And
I
like you
agree.
talked about the rest,
Yeah,
yes,
I agree with
like
these
you talked about
points.
the rest machining. Like you
Hmm.
talked about rest machining, so I just wanted to add here. So, like I earlier also said, so I have seen many of the time that the people are not putting the programmable coordinates as per the cutter program. So it is very important to add that thing. Maybe you discuss with the cutting tool supplier for which you are in the tool. You should be discussing with them. You should be asking them the right parameter which needs to be put into the program, and then maybe running the program which can give you the best out for your program and for your tool.
Absolutely, absolutely. The finally the comes into the uh, think of surface quality or finishing. That is the final step of the die mold industry. So software, today's world, the software has the capability distribution of points. Say for example, as I explained you, if you get a good geometry, if you collected a good geometry, but if you are not able to convert those geometry into a toolpath or the chips toolpaths, it's a toolpath, so it will not create a final output. So for this, so software has a capability of cost consistency, like if you have a steep area as well as the shallow area, because most of the die mold industry will find both the things. So the software should have capability to distribute equal consistency of the cost value. Cost value is distributed equally for the steep and the shallow area, then only you will get a better finish. As well as the tool engagement, how the tool is engaging from one location to the other location, that is also play important role. Smooth rotational in the sense I am talking about the smooth points. There is a many options within the software which can help you to distribute the points. For a line I may require 2 points, but for an arc I may require 3 or more than that. But depending upon the profile, depending upon the shape, the software can decide and you can give the options. You should know those options, you should discuss with us. So this options give you uniform distribution of points. So any 3D profile complex shapes that can be covered with those strategies, that's give you the more confidence of the outcome. Cycle time, surface finish, everything can be controlled with the good quality of tool, good quality of strategies, good quality of holding devices, machines, and by using the right parameter right strategy, you can also reduce the manpower, That's the one we are talking about, the savings. This is the saving of machining hour cost, labor cost. These are the major cost we can talk, discussing about this. Sandeep, I think we have done one
Yes.
success story. Can you just highlight it on those success stories?
Yeah. Next, please. Yeah. So this is what government can do for our customers. So this is a success story where customer was struggling with a high time of 38 hours, and what we achieved is actual machining time of 18 hours on machine on a spindle. So what we did differently. So you remember the eight process what we presented in our presentation earlier. So we tried to eliminate those eight process. We moved to AI time. We went for a right cutting strategies in deep cavities. Maybe we talked about the dynamic milling. We went for the dynamic milling strategies. We tried to reduce the number of cutters. Maybe where we check the gaps in between the dies where we can put the maximum diameter cutter so that maybe your tool can get better rigidity and the deflection could not happen, and maybe you can run for a higher cutting parameter. We went for a tool where we can take a more depth of cut. We can go for a more cutting parameters. So all these things resulted, maybe I would say the software and the cutting tools. They came together, and the result is in front of you. Maybe where we could able to save a huge cycle time for customer, and it really gives a good benefit to the customers.
Yes, Sandeep. This is the perfect example. I'm again and again saying the programmer was not doing wrong because you are just using the
Yes,
conventional process. He is just
right.
following the process has been given by the earlier days, so it is just following that. But understanding of tool, as I told you, some slides, every tool is not meant for the all applications. So by talking to the tool and talking to the software people, so we can able to guide him. This tool has to use for this application roughing, this tool has to use for finishing application, this strategy has to use to maximum material removal. So this help, we are not done a magic, but this collaboration will help everyone by coming from 38 to 18 hours. It's not a joke. It's a big
Yes.
achievement, I'll say. It's a big achievement. So I am again and again suggesting, talk to us, contact us, understand the reality, today's reality, what is in the market, what kind of a tool I have to use, what kind of a software I have to use, then how we'll achieve our finishing, how to reduce the cycle time. I hope by this all example, those informations, I hope everybody has collected a vital informations, and they should definitely contact us to understand their requirement. With this, I'll just open this forum for the question and answer. We are ready to give you the answer for your questions. Hand it over to Priyanka.
Thank you, Sandeep and Sitanshu, for your technical details. Your presentation clearly demonstrated how advanced tools combined with intelligent software strategies enable stable processes, superior surface finish, and measurable productivity gains in die and mold machining. Now, we are here is quick poll time. We'll just wait a minute, I guess. Okay, now moving ahead to Q&A session.
Yes.
We'll now move ahead to Q&A session as
Hi Priyanka, thank you. So basically, thank you Sitanshu sir, thank you Sandeep sir. So basically, we received some few questions, interesting questions from our attendees. So on to the next questions. The first question is from Yogesh. So first question is, how do you do semi-finish of master can?
Yeah. As I told you, we have an option of roughing as well as the semi-finishing. Semi-finishing can be done in different ways. Most important ways is the stock model. The software understand my previous tool applied to the stock material and the left out stock. Also, we have an option for previous tool only. Also, we have option for previous tool paths. So we have a multiple options, but I'll always prefer that stock model exact. It will calculate what kind of a stock left out after this particular tool paths. So that give you minimum air cutting. That's what we are discussing initially, how to reduce the minimum air cutting because it's focusing on the particular left out material.
Great. Thank you. That definitely would help our attendees. So on to the next questions, again from the Yogesh. So how to calculate table feed in VMC?
It's not clear. It's how to calculate.
Table feed in VMC. So I think it's
Sandeep,
regarding the
So
machine.
regarding the
yeah, so table
parameter
feed.
you are asking. So
Yeah, so table feed in VMC maybe again. There is a simple formula for calculating the feed rate is equal to this in generally in VMCs and in HMCs in machining center the feed rate kept is per minute, and the formula is very simple. The feed per tooth in number of tooth into your RPM. So this is a very simple formula like where you can get the feed per minute. So for example, maybe it's if you're uh, if you are putting a feed rate of 0.1 and your cutter is having 8 teeth, so it will be 0.1 into 8 into the what will RPM, and you will able to get the feed per minute.
also you have to consider the material as well.
Exactly. So basically, a cutting speed and the feed per tooth, you should be going with the from the material point of view, it will be completely different. And the hardness and the tensile strength, you need to look for the hardness and the tensile strength of the material. And accordingly, the machinability of the machinability of that particular material will be decided, and then only you can maybe put a cutting parameter.
Absolutely.
Great. Thank you, Sandeep sir, for real insights. So on to the next question from the Yash. It's when machining in real time, the component surface is variable and not 100% flat. And if we do not take measure tool can get damaged. Does machining take into account?
Absolutely. I was explaining the same thing. Die mold industry, there is a major area, steep and shallow area. It's not a flat area. It's a combination of both the steep and shallow locations. So by finishing strategy, point distributions, selection of particular tool, definitely it will give you a better surface finish. That's the reason I'm more and more emphasizing about the uh, entry exit, cut consistency and the smooth movement. These three will define your surface finish. That strategy, Mastercam has those strategy along with that tools and importantly the tool selection. So everything has to be combined to give a better surface finish.
Yes. Thank you, Sitanshu sir. That was a great insights. So basically, thank you everyone for the excellent questions once again. Okay, so for that bring us to the end to the sessions and like on to the Priyanka to carry on the
yeah.
next.
Thank you,
Yes.
Rishi. Thank you, Sudhanshu and Sandeep. Thank you for your excellent questions and active engagement. Now we will move ahead for closing up and follow. So you have on your screen if your questions wasn't addressed today, or you would like to explore specific applications further, please scan QR code on your screens to get in touch with your account managers. So I'll be keeping the screen for like minute or so that you guys can scan it and get in touch with us. You can also scan it for full range of tooling and software solutions. Please scan this QR code. And the session recordings and material will be shared with you through an email shortly after this event. I hope you guys have scanned the QR code. Please get in touch with us. Get in touch with our account managers. We will be able to help you then. Okay, thank you for joining thank you once again for joining in and Milling in Sync tools and software for peak performances. We look forward to welcome you to the next session of Machining Harmony series. Until then, stay safe, keep innovating, and keep machining in harmony. Thank you.
Thank you so much.